Hello, my colleagues and I will be presenting to you why we need to include renewable energy systems into our state strategy, and we'll show you the consequences of what will happen if we don't. So why do you think we need to do this? At the current rates of energy consumption and the resources that we are using to sustain them, for example, crude oil, we will be running out of materials very soon, alongside leading the future generations to a world with catastrophic effects of climate change. Okay, so you're saying future generations. Well, it's not affecting us now, so why should I care? Well, that's wrong. The effects of climate change are already being felt in different parts of the world. For example, deadly wildfires to tropical storms. We see these examples every day. In order to allow the future generations to experience the beauties of the world, we need to make a change now. This starts with the transition to renewable energies. Okay, so how would we fix this? Well, let's start with using resources that, first of all, we can't run out of. Second of all, don't have to drill for, and we can always rely on them being there every single day. So what comes to mind is sun, waves, and wind. One form of renewable energy systems would be solar facilities. Solar facilities rely on one of the most reliable and inexhaustible resources that we have, the sun. The process of transferring energy from solar facilities is pretty easy to understand. The panels reflect sunlight towards a solar tower. The solar tower then processes this thermal energy to heat the liquid that is held inside, which then generates steam. The steam then powers a generator, which produces electricity. We then transfer this electricity to nearby cities in order to power thousands of homes and businesses. So what happens when the sun goes down? Well, we can use tanks filled with molten salt that can absorb this thermal energy that is conducted throughout the day for hours after sundown. Oregon's wonderful rural landscape allows us to build these facilities without destructions of cities. We have chosen to place these facilities in the southern eastern parts of Oregon because, as you can see from this atlas, those are the areas that absorb the most solar energy throughout the state. So it just makes sense to place them there. Solar energy, along with the next few renewable energy systems, are the future and are the smartest ways of using the Earth's resources to create energy without the use of exploitation.
Wave power is power drawn from waves of seas and oceans. Imagine using what our planet is 71% covered in to allow us clean energy without destroying it. When wind blows across the sea surface, it transfers the energy to the waves. The energy output is measured by wave speed, height, and wavelength. Wave power devices are generally categorized by the method used to capture the energy of waves, the location and power takeoff system. Energy density for wave power is determined by the mean energy flux crossing a vertical plane parallel to the wave's crest. Compared to other major renewable energy sources, wave energy has a high energy density, and this energy source is predictable at any site. My team and I will be using one kind of wave reader at each site, and they are called sea snakes, also known as Pelamis wave energy converters. The machine is long and narrow like a snake and points into the waves. The sections of the device articulate with the movement of the waves, each resisting motion between it and the next section, creating pressurized oil to drive a hydraulic ramp. This kind of energy is free, and no fuel or waste is produced. It is not expensive to operate and maintain as well. And finally, it can produce a great deal of energy.
The final renewable source of energy we plan on incorporating is offshore wind energy. The 3 facilities will be located in southern Oregon, 4.5 miles off the coast of Gold Beach. This area was cited because of the high rates of wind capable of powering the farms as seen in this chart, measuring wind rate, where the darkest shades of blue had the highest rate of wind. Per the public's concern for the aesthetic value of our coast, the farms will not be visible by the naked eye from the shore because they will be situated just past the horizon line. Each plant will consist of 312 deep-water monopile turbines capable of producing 8 megawatts of energy. Monopile turbines are most commonly used in offshore facilities because they have the lowest ecological footprint. The difference between this model and others is that a large portion of the turbine will be planted within the earth. Each turbine requires 60 acres of surface area and 8 rotor diameters between adjacent turbines. This is better conceptualized than the drawing displayed. The facilities will each have a mile distance between one another to prevent the wake effect, in which the rotation of turbines disrupt one another. Each offshore wind farm will be capable of producing 2,496 megawatts of energy. This amount of energy could power 409,344 homes in Oregon. In addition to the turbines, we would build offshore structures for those who work on the wind farms. Not only will these plants produce a significant amount of energy, it will also provide employment for those who are interested in maintaining the plant.